Hello, everyone, and welcome to another episode on this very channel. We are still on how to solve questions on compound experiments. Remember, we are still on the same topic, probability. If you have not subscribed to my channel, kindly click on the subscribe button for me. So in this video tutorial, we want to look at this particular question on the board. So let's read it together. Two fair dice A and B, each faces numbered 1 to 6 are thrown together. We want to construct a table showing all the equally likely outcomes. And then B, from the table that we have drawn, we want to list the pairs of numbers on the two dice for which the sum is 5. The sum is what? 10. C, we want to find the probability that the sum of the numbers on the dice show the same scores and then different scores. This is our task for the day, and we are going to go through it one after the other. So the question is saying that we are having two fair dice, and we know that when we toss a die, we are either going to have the number 1, 2, 3, 4, 5, or 6, and then we have die B. When we toss it similarly, we are going to get these outcomes: 1, 2, 3, 4, 5, and then in listing all the set of possible outcomes for this compound experiment, we are going to draw our table to help us find the set of possible outcomes when these two fair dice are tossed once or they are tossed together. We are going to use this rule to represent the toss of die B. So we have B, and then we are going to use this column to represent the toss of what? Die A. You know that when we toss die A, we are either going to have 1, 2, 3, 4, 5, and then 6. And then when we toss die B, we are also going to have the number 1, 2, 3, 4, 5, and then 6. What we will be doing next is to pair the outcome from the toss of die A with the outcome from the toss of what? Die B. So this is what we are going to have. So we are going to have 1 and then what? 1. So we have 1 and then 1. Then we pair 1 and 2, so we have 1 and then 2. Then move on to 1 and 3, 1 and then 3, so we have 1 and then 3, 1 and 4, so we have 1 and then 4, 1 and 5, 1 and 6. Let's use the comma to separate them. Then move on to the number 2, 2 and then 1, so we have 2, 1. We have 2, 2, 2, 3, 2, 4, 2, 5, and then 2, 6. Then move on to 3. So we have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, Now you know the pattern, so you can continue the rest. All these outcomes in this arena become the set of possible outcomes when two fair dice are tossed together. Once we are done with this, we move on to the number of outcomes in the sample space. So we have a number of outcomes in the sample space. So with this, we are going to count the outcomes one after the other. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6. So we have 6 times 6. That gives us what? 36. So it means that the total number of outcomes in this sample space is what? 36. Now once you know this, we can move on to B. From the table, we want to list the pairs of numbers on the two dice for which the sum is equal to 5. So we have I. The sum is what? 5. So this means that we are going to look through the set of possible outcomes to see which pairs of numbers that when we add them, we are going to get the number 5. So from here, you can see that when we add 4 plus 1, we are going to get 5. 3 plus 2, we have 5. 2 plus 3, we have 5. 1 plus 4 will give us 5. So all these pairs of numbers, when we add them, we are going to get the number 5. So let me use the blue ink for us to see it clearly. So we have this. So all these pairs of outcome will give us 5. We have to list them. So we have 4, 1. We have 3, 2. We have 2, 3. We have 1, 4. Then we have sum up to 10. So we have sum up to 10. So we have to look through the set of possible outcomes to see which pairs of numbers when added will give us what? 10. So from here you can see that 6 plus 4 will give us 10. 5 plus 5 will give us 10. 4 plus 6 will also give us 10. So let me use the green ink for us to see clearly. So let's list them. 6 and then 4. We have 5 and then 5. And then we also have 4 and then 6. Very, very easy. All these pairs of numbers here will give us less than 10. And all these pairs of numbers here will give us the sum, which is more than what? 10. Now let's look at C, finding the probability that the sum of the numbers on the die show the same score. So the same score means that we can have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then 6, 6. So with that, you can see that we have 1, 1 here, 2, 2, 3, 3, 4, 4, 5, 5, 6. So that is the same scores, the same numbers. So let me use this for us to see clearly. So we have same scores. We have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then 6, 6. So we have to find the probability, right? So we have to find the number of outcomes in the same scores. So we have to count them. 1, 2, 3, 4, 5, 6. So we have 6. So you can see that the probability of obtaining the same scores is equal to 6 all over what? The total outcomes in the sample space, which is what? 36. We can break it down to give us what? 1 over 6, as easy as that. Let's look at different scores. So we have to find what? Different scores. With the exception of those pairs of outcomes in this diagonal line, all the pairs of outcomes are of different scores. Now, the pairs of outcomes which shows the same score, they are 6. Therefore, the pairs of outcomes which will show different scores will be what? 6 minus 36, and that is going to give us what? 30. So we have 30 outcomes which shows different scores. You can count them one after the other. You can count all of these outcomes with the exception of those pairs of outcomes in this diagonal line, and you are going to get 30. Since we have to find the probability of obtaining different scores, so we have probability of obtaining different scores we are going to have 30 all over the total number of outcomes in the sample space, which is 36. You can break it down, right? So we have 5 and then what? 6, and that's going to give us 5 all over 6. So probability of showing different scores is equal to 5 all over 6. As easy as that. This brings us to the end of today's lesson. See you tomorrow. Bye bye.